Now let's look at probabilities involving ORs, right? So, which is going to be union of probabilities. So suppose that you have two events A and B, and you are interested in the probability of A or B, which is the same as saying the probability of A union B. And so what this tells us is that this is going to be the probability of A plus the probability of B minus the probability of the intersection here. And so this follows directly from inclusion-exclusion, which we have seen before. So remember that in general, when you take the union of two sets, this is going to be the cardinality of one of them plus the cardinality of the other one minus the cardinality of the intersection. Why? When you did the Venn diagram, so if this is A and B, when you're counting the amount of elements in A, you are counting, let's say, this over here. When you're counting the amount of elements in B, you're counting this over here. And notice that the intersection was counted twice. So you need to subtract it once from there. So that's why you get this rule here. And then, of course, if you divide on both sides by the cardinality of the sample space, so if you do this here, then you get exactly this expression here. So this is the probability of A union B, this is the probability of A, this is the probability of B, this is the probability of A intersection B. And so let's see an example where we could use something like this. So let's say you draw a card from a standard 52 card deck. What is the probability that the card is either a heart or a king? And so you're going to have how many hearts you have, how many kings, but again, there's going to be some intersection because there is a king of hearts also, right? So let's count this. So again, if we make A be the event, draw a heart, and B be the event, draw a king, well then what is the probability that you draw a heart? So the probability that you draw a heart is going to be, so how many hearts do you have in the deck? You have 13 of them out of 52 cards. So this is the probability that you draw a heart. What is the probability that you draw a king? Well, there are 4 kings in the deck, and the deck has 52 cards, so it's 4 over 52. And we also need to know the intersection. So what is the probability that you draw a heart? What you draw, let's say, is a heart and a king, right? Well, there's only one king of hearts in the standard deck, so that will be 1 over 52. And so what the theorem tells us then is that the probability of A union B that we're interested in, the probability of drawing a heart or a king, is going to be the probability of A plus the probability of B minus the probability of the intersection, which will be 13 plus 4 plus 1 divided by 52. So this will be 16 divided by 52, which if we simplify, this will be 4. So 13, 14, 15. So not 16 actually. Oh yeah, so sorry, this is a minus here. So it'll be 13 plus 4 minus 1. So that's 16 over 52, which will be 4 over 13. And 4 divided by 13 is approximately 30%. So what is the chance of drawing a heart or a king? Around 30%.